Okay, today's lesson is on looking at the trig graphs, the trigonometry graphs. In order to access this lesson, it'd be a good idea to go back and look at the Key Stage 4 lesson on trigonometry, because it will make a little bit more sense, okay? Now the aim is, after we've drawn these graphs of y equals sine x, y equals cos x, and y equals tan x, we're then going to solve some trigonometry equations using the graphs. And then I'm going to teach you another way of being able to solve trigonometry equations, which is called the cast method. Okay, so let's look at the graphs first of our trig functions. Let's remind ourselves of our trig functions. We've got sine is one of our ratios. Remember, sine ratio was opposite over hypotenuse. Then we had cosine. Remember, the cosine ratio was adjacent over hypotenuse. And then we got the tangent ratio, which was opposite over adjacent. And those are our three ratios that we used in trigonometry to be able to find missing sides and missing angles, and obviously using the sine and cosine rule in non-right angled triangles. So what are we going on to now? Then we're going to have a look at the graphs, because these are functions. Sine x, cosine x, tangent x, they are all functions, and they have graphs. They have their own individual graphs, no different than any other function in x. So often you can get asked to sketch the graph, okay, of y equals sine x, y equals cos x, or y equals tan x. Now, if you were doing this question and you had a scientific calculator in front of you, then you could also just put some angles in. Do sine of 0, sine of 90, sine of 45, sine of 125, sine of, I don't know, 245, sine of 360, and you'd be able to get the shape of the graph yourself. I'm going to just concentrate on the key elements, which are 0, 90, 180, 270, 360. I'm also going to extend, okay, negatively, because this graph goes on forever, okay? It's a constant graph that repeats itself. So, why have I got the axes +1 and -1? Well, just to remind you, the ratio for sine cannot go above +1 and -1. Why? Because the hypotenuse, remember, it's the opposite side divided by the hypotenuse side. The hypotenuse side is always going to be the largest. So the graph cannot go above +1 and -1, just like the cosine graph can't, +1 and -1, because you're dividing again by the hypotenuse, because the cosine ratio is adjacent divided by hypotenuse. So if we go to a calculator and literally type in the sine of 0, you would get nothing. Then if you took 90 degrees and did the sine of 90, you would get +1. Then if you did the sine of 180, you would get 0. If you did the sine of 270, you would get -1. And if you did the sine of 360, you would get 0. So that gives us the shape of the sine curve. Notice the sine curve starts at 0, goes up like that. Okay, it's a smooth curve, down like this, up like that. So what do we notice about this graph? It's an oscillating graph, it repeats itself, it goes up and down like this, goes on forever, it doesn't just stop at 360 degrees, but also it can go negatively as well. And what basically happens is it starts repeating itself, okay? So basically it will come down here, so sine of -90 is -1, and we've got -180, -270 is +1, -360 is nothing. And you've got a lovely sketch there of the graph of y equals sine x. Let's look at the graph for y equals cos x. Same thing. If you went in and typed in literally the cos of nothing, you will find you get 1. When you type in the cos of 90, you get 0. When you type in the cos of 180, you get -1. 270, you get 0. And 360, okay, you get 1. Showing those points up there, smooth curve again, okay, going through those coordinates. And you've got the general shape of that cos graph. And again, it will just keep going, okay, in exactly the same way. Also negatively, if we do the cos of -90, it comes nothing. -180 is -1, -270 is 0, and we've got the cos graph, okay? Now, what does that allow us to do? Well, basically, we'll very, very shortly, after I've drawn the tan graph, we'll be looking at being able to solve trigonometry equations using these graphs.